Let's do a couple of examples here. In 1, 2, 3, I've got the matrix below, and it says to find a basis of its row space, and then find a basis of its column space using method 1 and then method 2, and then tell the dimension of the row space and column space. All right, so probably should have typed this in already, but I haven't, so I'll go ahead and type it in here. I always call my matrices M for no reason other than short for matrix. All right. Okay, there we go. So if I take the reduced row echelon form of this, I get this. So that gives me, let's see, the top one is 1, 0, 1, 0, 0, 1. Next line gives me 0, 1, 1, 1. 0, 0. And then 0, 0, 0, 0, 1, negative 1. All right. Let's hide this for the moment. So from doing that, I'm going to do these slightly out of order. A basis of the row space. I didn't leave myself a lot of room here, so I'm not going to write that out. I'm just going to say for part A, a basis for the row space is going to be top, that. Basically, we need all three rows because they're all non-zero. That last row is 4 zeros, a 1, and a negative 1. All right. Let's see. While we're at it, let's circle the leading ones here. We've got one in this column, and this column. So it's column 1, column 2, and column 5. So that gives us a basis of the row space, but that's using the second method. So I'm doing C before I do B. So that's going to be 1, 0, 1, 0, 1, 0, and then 0, 0, 1. All right, now for B, part B. We want to use the other method to come up with a different basis for the column space. So let's look at octave again. Make octave a little bigger here. All right, so we've got the matrix M. If we take its transpose, we get this. Now I'm going to do the reduced row echelon form of that. When I do that, I get this. So for part B, let's see, what do we need? We need the non-zero rows of this, but we're going to write them as columns. We get 1, 0, 0. 0, 1, 0, and 0, 0, 1. Like that. All right. So that's parts A, B, and C. Notice B and C gave us two different bases, but both of them have 3 elements in them, and they're both, consist of elements of R3. A consists of elements or vectors from R6. All right, now part D. says tell the dimension of the row space and the column space. The dimension for the row space is 3, because there are 3 vectors in there. And the dimension for the column space is 3 because there are 3 vectors in there. So both have dimension 3. All right.